The Couchbase Developer Database Platform is designed for superior performance, flexibility, and low cost. It provides scale, speed, and multi-purpose capabilities for building, deploying, and managing agentic applications. Core capabilities include operational database services with in-memory key value lookup for speed and distributed JSON document storage for scale and development flexibility. Mobile edge services to power apps with vector search and data sync, even without internet. Analytics services with zero ETL and the ability to write back to operational systems. And AI services for developing and deploying agentic apps, which leverage Couchbase's super-fast billion-scale vector search indexing. Let's see how AI services help accelerate agentic app development. Suppose we're setting out to build an AI-powered vacation planner agent that can arrange hotels, flights, entertainment, and amenities. There are certainly many tools and approaches to choose from, but it isn't easy. Here's a basic flow of critical steps required for any AI-based agentic application. You have to consider preparing your operational data for AI, which requires vectorizing it for RAG and semantic search to provide context for agents. You have to consider unstructured data from outside your operational applications, like PDF travel guides and event promotions that can inform your app with valuable data for recommendations and advice. You have to consider AI models, not just which ones to use, but where they are located. Publicly available cloud models are powerful and widely used resources, but they're out of your control, and so present issues with governance, security, privacy, and latency. And for evaluating massive amounts of data quickly, how do you easily leverage LLMs to do things like determine entities and sentiment across an entire database of information? And agentic apps use tools and prompts to parcel out tasks and perform them at lightning speed for the user. But as agents interact with users and each other, how do you capture their responses? And more importantly, how can you trace things like agent drift and hallucinations? Of course, all of these requirements can be achieved today, but it typically involves a complex architecture of loosely interconnected technologies that is hard to manage, inefficient, and wholly unrepeatable. Capella AI Services provides a comprehensive ecosystem to do all of these things easily within a single powerful database platform. For our AI Travel Coordinator app, we want to use our operational data on hotels from our travel database to power recommendations and offers. In order to do this, we need to vectorize the data so we can use it for semantic search and RAG. Let's use the data processing service in Capella. Here in Capella, the AI Services tab gives us access to every available AI Services resource. I'll simply create a new workflow to vector encode our hotel data in Capella. Next, I'll specify the source data, in this case, our travel database hotels collection. Next, we can set which fields we want to vectorize, all fields in each document, or just specific fields. Let's set this workflow to vectorize the description, name, and reviews fields in the data. I'll also select to create the vector index with this workflow. Now we set the embedding model. We can either use a Capella hosted model or use an external model directly. I'll select a specific OpenAI model, then I'll deploy my workflow. Once it's running, we can see the results in our travel app database. Every hotel document now has a vector embedding and is ready for AI. Our travel planner agent needs unstructured data, like PDF travel guides, to inform semantic searches and LLM suggestions. But how do we include this data? Let's use the data processing service in Capella. We begin in AWS S3, where we see a bucket containing PDF resort guides. Let's open this PDF for Couch Hotels and take a look. It has basic unstructured information on the resort activities, amenities, weather expectations, entertainment options, and more. Great data for our travel app. We need to store the information from these PDF documents, as well as vectorize it for use with AI. And Capella AI Services makes it easy. We'll create a new workflow and click to use unstructured data from external sources. For the source, we'll select an existing AWS S3 bucket integration, which uses S3 connection keys securely saved for reuse. Here we'll select the travel guides collection created earlier on Capella as the destination for the PDF data. Next, we pre-process the data for chunking and vectorization. We can select specific pages, exclude elements, and choose a chunking strategy. Let's use a paragraph splitting chunk strategy. Now we set the embedding model. We can either use a Capella hosted model or use an external model directly, which we will select here. The workflow deploys, and once it's running, we can see the results in our travel app database. Now the travel guides collection on Capella is full of data from the PDF documents, chunked, vectorized, and ready for AI. The Capella Model Service deploys models right alongside the hosted database. minimizing latency and data privacy risks by ensuring data never leaves your VPC. And it provides more control overall than using a general-purpose cloud LLM. Clicking the Managed AI Models tile in Capella AI Services takes us to the Model Configuration tab, where we'll deploy a hosted LLM. Capella offers an ever-growing list of models to choose from, both LLM and text embedding. Options include DeepSeek, Meta, Mistral, Snowflake, and of course, NVIDIA models, including the NVIDIA Nemotron Super. Here we'll select a DeepSeek Llama LLM to deploy. And now's where the real control comes in. We can configure value-added services on our hosted LLM, such as quantization and optimization, to shrink and optimize models without sacrificing accuracy. Guardrails establish a list of moderated topics that the LLM must not engage in. You can also choose to detect and block jailbreak attempts. Semantic caching allows us to store and reuse LLM responses to prompts based on semantic meaning, as well as store conversation threads, which can be picked back up at any time without repeating details, all saving valuable processing cycles. Keyword filtering allows us to exclude words from user prompts and LLM responses, such as competitor brands. Now, with all the value-added features configured, we can deploy the model. Now we have a hosted, secured, and fully governed GenAI model on Capella to use with our applications, which will make them faster, more controlled, and more private. Models on Capella can be easily accessed via a simple endpoint URL. With the model service in Capella, we were able to quickly and easily deploy a hosted LLM, including value-added features like caching, guardrails, and keyword filters for governance and control. Suppose we want to leverage an LLM for sentiment analysis or summarization across a large volume of data, perhaps thousands of hotel reviews. Instead of wiring up a complex pipeline of data through a machine learning engine, AI functions in Capella AI Services lets us use SQL queries to invoke LLMs directly when working with data stored on Capella. Let's take a look. Once associated with an AI model, AI functions can be used right away. The predefined functions include sentiment, entity extraction, classification, grammar correction, text generation, entity masking, similarity, translation, summarization, and completion. Developing agentic apps is the best way to deliver a fast, compelling, and personalized experience. But as developers create more and more tools and prompts, these building blocks can become difficult to manage. And once agentic apps are deployed, issues and errors in specific agentic sessions can lead to hallucination and drift. But how do you trace them? With the Agent Catalog. The Capella Agent Catalog is an SDK that accelerates agentic application development with a methodology and centralized repository for tools, metadata, prompts, and audit information to manage LLM flow, traceability, and governance. Once the SDK is deployed and connected to Capella, prompts and tools are cataloged in Capella, where they can be browsed and searched. The Tools Hub displays all of the tools in our catalog, where we can open and examine them in detail. Similarly, the Prompt Hub is a searchable list of prompts in the catalog. The Agent Tracer captures and logs all agentic sessions in Capella. Simply select any session in the cluster, and we can see the progression of activities and decisions that the agents made. Here we see the input data for the tool, and the first successful response. But more importantly, we can see an unsuccessful response, a tool response that contains an exception. With this valuable insight in Capella, issues like hallucinations and agent drift can be more quickly diagnosed and resolved. With capabilities for automatic vectorization, unstructured data processing, model hosting with guardrails and caching, AI functions for calling LLMs with SQL, and an agent catalog framework, Capella AI Services helps developers efficiently and effectively create and operate GenAI-powered agentic applications. Learn more by clicking the links in the description below. And thanks for watching.